Hello. Yeah, this is lecture 7.2, continuous random variables. We already talked in 7.1 about the continuous random variable. And what we're going to do in this lecture is to define some function. We call it probability density function, abbreviate like a PDF abbreviation. And what does this function? This function is the x-axis itself is the random variable, and the y-axis is the, let's call it f of x, which is the probability of each value of x. Since x is continuous, it could get any values. And we know that integrating this function from minus infinity to plus infinity must equals to 1. And that 1 means 100%. That's the meaning of the probability. What's new? If we know this function, for this lecture and the problem solving, the seminar for this lecture, this function will be given. So this function is going to be given, and basic also, not that complicated function. So if this function is given, what can we get? We could get a lot of things. First, we could get the mean from the function. How? I'll show in next slide. We could get the variance, and we could get the mod also. So these three things, we could get them as soon as we know the PDF, the shape of it. Anything else we could get? Yes. If we integrate this function without limits, like regular integral, integrating a function is going to give me another function. That function, how they call it, CDF, stand for cumulative distribution function. So I have this function, I integrate, I get another function. So if I get this, what's the advantage? What can I get from this? We could get the mean, median. Yeah, quartiles. Median is just a specific case of quartiles, it's Q2. So we could get Q1, Q2, Q3, Q any, like whatever they ask. So we are looking for 5 different things. All these we could get them from this function, the PDF. I'm going to split this lecture to 2 pieces. The first one roughly 15 minutes, and the second one like around 30 minutes. So just I suggest after the first part, the 15 minutes, try to solve some problem that I already solved, or take a look to the seminar and try to match, and then start the second part. It's just recommendation. It's up to you, the way you handle your job. If you think the lecture and the problem solving sheet is not enough for you, you could go over these references for more reading and practicing. How to get the mean if the PDF is given. The mean is defined like that. Sometimes they call it expectation value. It's the same as the mu. It's integral from minus infinity to plus. So this is finite, also finite, because these are numbers. We will see these are finite number in our case, because our function, it's really basic. To get the mean, we need to multiply the PDF, which is given, by x, and then we get another function. We perform the integral, and that's it. To get the variance, we need to multiply the PDF by x squared, and then perform the integral. We are going to get a finite number, as I said, because negative infinity and positive infinity, for all the cases we are going to deal with in this lecture and the seminar, will be just finite numbers. And then you need to subtract mu squared. Where is the mod? I'm going to postpone the mod for the next part. So let's focus on the mean and the variance. Function PDF is defined piecewise equal to a straight line within this interval. So look, our minus infinity will be replaced by this one, and the positive infinity will be replaced by this 3 if we want to perform the integral, because the function covering nothing everywhere else. So that's the only zone we are caring about, the area under the curve. What they want, they ask us to calculate the mean and the variance. Let's start with the mean. The mean equals the function itself multiplied by the variable, integrate from minus infinity plus infinity, and we are going to replace minus infinity by 1, positive infinity by 3. That's our variable, and y over 4 is the function itself. And then, as you see, this is an easy integral. You just multiply y by 1, you get y squared. Integrating y squared dy is just y cubed over 3. And then you need to substitute your limits, perform this, and you're supposed to get this answer. I recommend you to hide this solution, start from this, and that's the definition how to calculate. Replace minus and plus infinities with these limits, and then perform the integral and see if you are going to get this answer or not. Calculating the variance is the same technique. We need to multiply the PDF by y squared and then subtract the mean square we get from the previous part. So again, change these to whatever the question give you limit and perform the integral. Change it, y squared multiplied by y over 4. This is y cubed over 4. Integrating y cubed is going to give y to 4 divided by 4. Okay, but we have another 4 in here, that's why we get 16 in here. Then substitute, and don't forget to subtract. This is the mu square, the one we get from the previous slide. Again, milk it to the end. We are going to end up with 11 over 36. So again, try to hide this solution. Start from this and that. Change the integral limit. Substitute the value of the function. Simplify. Perform the integral and try to get this answer. Instead of finding expectation value of x or variance of x, now we need to find the variance of ax plus b. We already did see this with the previous lectures. So I'm not going to in details how we get this. I'm just going to show you the final answer. Expectation of ax plus b equals to a itself multiplied by the expectation of x, so that's the mean itself, and then add b to it. For the variance, you need to multiply by x squared. So what should we do? Let's go and do the same example we did solve. That's the same example excuse me, we did solve the previous slides. A and B already we got them. Now in C and D, they ask us to find expectation of 2y minus 3, variance 2y minus 3. We know E of x, our A is 2, our B is minus 3, so we need to multiply this 2 by that, and then the result added to minus 3, and that's it. So we are going to use the result from this one. Here are the results from the previous one. This one is, we find it 13 over 6. Our A is 2. Our B is negative 3. So we get that. For this one, our A is 2, but we need to square it. So we get this 4. And our variance, whatever we get from the previous slide, just plug it in and try to see if you are going to get this value. Straightforward. Another example. In this example, the PDF is a parabola with a leading coefficient of -1. So this parabola is facing down. And they ask about mean and the other things. They say, what's the probability for x greater than mu? We need to find mu first, and then I'll show you how to calculate this. How to find the mu? Two different ways. Either following the same procedures we did with the previous example, like integrate from -1 to +3, multiply x by this function, and integrate term by term, and substitute, then you get what you need. That's one way. The other way, you could see that this is not that hard function to be sketched. If we sketch this function, we could get the line of symmetry, because all the parabola, they have a symmetric line, that the one passing through the turning point, or we call it the vertex. From that, we could get also what we need. It's up to you, like choose the flavor you like. Sketching the function, we find that the roots are -1 and 3, and the distance between these two roots is 4 units. So the midpoint is 2 units away from each edge. Then the straight line x equals to 1 is the symmetric line for this parabola. So when x equals to 1, that is not just the mean, that's the mod also. I'm not going to talk about the mod right now, because this is a specific case when we have symmetric distribution. This is general information. When we have symmetric distribution, then the mean is the mod itself. So let's focus on the mean. Well, obviously the mean here is 1, but we could verify it. How to find this, the value of x? This is the x component of the vertex of the parabola, where b is the coefficient of x and a is the coefficient of x squared from the parabola. Substitute, we will end up with x equals, when x equals to 1, that's the symmetric line, and this is the expectation value, or the mean itself, and the reason is the symmetry. Let's go and solve for the variance. For the variance, now we know let me put the graph in here. Look to the graph. We know mu is equals to 1. You could verify this one by using the integral, as we did in problem number, like example number 1. And this function, the red one, is the PDF itself. The area under this curve must equals to 1. And since this is a symmetric, then the area from this line to the right equal the area from this line to the left. So each area equal to 50%, which is 1/2. So the probability for x greater than 1, means from 1 to 3, because after that there is no areas going to be covered by the function, is to 1/2. As simple as that. You could verify, we are going to solve it using, and here we are going to solve it using the integral. So if we integrate from 1 to 3, because that's what, this is mu itself, to 3, and then we put the PDF itself as it is. Pay attention, you don't need to multiply by x. We are not calculating for the mean, we are calculating for probability. If you want to calculate for a probability, the only thing you need is the function itself, and then integrate from your limit probability, from where to where. In our case, from 1 to 3. Perform the integral, and then you are going to end up with the same result. That's the way. It's always like recommended, highly recommended, to go and solve a problem in 2 different ways. This will give you like more confidence in solving some other problems you may face difficulties with it. I think this is the end of part 1. So as I said, I postponed the mod for the second part. Okay.